Part 2, this is for question 7 to 11. Question 7 is coming from circles in coordinate geometry. The point A has 1, 5 as the coordinates, and then L has a gradient of -2/3 and passes through A. A circle has the center 5, 11 and a radius √52. Part A, show that L is the tangent to the circle. What we are going to have here, if this one is a tangent, let's say this is our circle here, and the center is given by 5, 11, not so? 5, 11. Then point A is 1, 5. 1 is on the left of the 5, and then 5 is below the 11. So maybe A is down here, which is 1 what? 1, 5. So we have to draw a tangent here. Okay. Now we should know from circle theorems that a tangent, okay, a tangent is perpendicular to the radius of the circle. So if I have the radius here, this is 90 degrees. A tangent is perpendicular to the radius of the circle. So what does this one mean? The gradient, therefore, gradient of the tangent, then times the gradient of the radius, okay, must be equal to what? Negative what? 1. That is what we must prove. So let's begin by finding the gradient of the radius. So gradient of the radius. So this one is going to be, we are using these 2 points. So changing y, that will be 11, then minus 5. The 11 here minus the 5 here. I'm not saying this 11 minus this 5, okay? Then we are dividing by 5, then minus 1. So 5 minus 1. This one will give us a 6, then over 4. And this one reduces to by 2, you get a 3. By 2, you get a 2. Okay. Now, gradient of the radius is 3/2. Then times gradient of the tangent. So gradient of the tangent is given as, or gradient of the line L, okay, is given as -2/3. Okay. So what do you get here? This is a -1. Okay. So since the product of the gradients is -1, that means L is a tangent to this circle. So I'll just say, therefore, L is a tangent to the circle. As simple as that. Then part B, they are saying that find the equation of the other circle of radius √52 for which L is a tangent to that circle. Now this one, suppose again I sketch this one, and it has its center here, and they are saying that L, right from here, this one, in fact, let me take away this here, what I've drawn. Let me just duplicate this one here, okay, and then bring it down here. So they have said equation of the circle for which this L here is also tangent. That other circle also has to be here, okay? That other circle has to be there. So let me just duplicate this, then put it here, like that. Then I can take away this, I don't need it. And also this one, I don't need it. I don't need this. So we need to find the the center of this circle here, because to find the center, to find the equation of the circle, you need the center and the radius. So the radius is going to be the same, root of 52. Even here, it is root of 52. Now, we don't know the center of this circle. Let's say it is AB. Now, this L here is going to become the mirror line. In other words, this one here is reflected in the L here. So they are having the same, what? Radius. And also this distance from this center to here is the same as from here to there. Also, so meaning A is the midpoint of the two centers. You see that? So A is the midpoint, of the two centers. And I've said that L, okay, L is a mirror line, that reflects the circle, in it. Okay, so we are going to have A, then plus 5 out of 2, then will equal to the x coordinate of A, which is a 1. Okay, the x coordinate of A is a 1, and then also B plus 11 out of 2 will be equal to the y coordinate of A, which is a 5. Now, making A the subject of the formula, we just cross multiply, right? So that means A is going to be 2 times 1, which is a 2. Then take the 5 this side. It is going to be a minus. So 2 minus 5, that one becomes a negative 3. Not so. Then B here is going to be, you also cross multiply 2 times 5, that will be a 10. Then when this one crosses, it's a negative. So minus 11. That means B is going to be equal to negative what? 1. So what does this therefore mean? That the center of the circle, the center of the reflected circle is negative 3, negative 1. That means its equation will be x minus 1 squared, then plus y minus, no, actually this one is going to be a 3, the x coordinate, so 3, then y minus 1 squared, then is equal to the radius, which is root of 52, and then we square it. So meaning we shall have x then plus 3 squared, then plus y plus 1, then squared, which is equal to 52. And this is our answer. Question 8 is coming from series, and in particular, this is arithmetic and geometric progressions. Okay, so the first, second, and third terms of an AP are A, 3 over 2 of A and B respectively, where A and B are positive constants. Okay, now, if we have A, then 3 over 2 of A as the second term, and then the third term is B, then that means there is a common difference in here. Okay, so meaning this D can be equal to the first term, the second term minus the first term, right? What does this one give us? This is 2, so 3A minus 2A, that will be A. So we shall get A over 2. You see that? And also B minus 3 over 2 of A will also give us the what? The D. Not so? A. So will also give us the D. So I can say right from here, we know that we know that what D is now A over 2, right from here, okay? Then is equal to B minus 3 over 2 of A. So if you can bring this one here, you'll have A, then plus 3. This is over 2, and then this one is also over 2 to give you B. So this will be 4A over 2, which is 2A. That means B is equal to 2A. I keep that one there. Then next, we are going to have the first, second, and third terms of a GP are these ones here. Now, we know that the first term of the GP, so here we are looking at the GP. In fact, let me separate this one. Here, I'm looking at what? An AP. So suppose I take this one, this side. We say we are dealing with an AP here. Now, first term is equal to A, then the second term, we are given 18, and then the third term, we are given B plus 3. Now, this one here is given by AR, and this is AR squared. So for us to get the common ratio for the GP, you get the preceding term, then you divide by the preceding term divided by the preceding term. So I can say get the second term, then you divide by the first term. It is the same as saying get the third term, divide by the second term. So to go to the next term, you multiply the previous term by something. Okay, that's what we call the common ratio. But then for the AP, to go to the next term, you add something onto it. You add or subtract. For the GP, you multiply or divide. Okay. All right, now let's go. So the second term is 18. The first term is A. The third term is B plus 3. Then over. The second term is 18. So when I cross multiply, 18 times 18, I think that is 324. Then this one is equal to A into B plus 3. Not so? Now our B is 2A. So we shall have 324, which is equal to A into 2A plus 3. So 324, when you open the brackets here, you have 2A squared, then plus 3A. So meaning the quadratic equation that is coming from here is going to be 2A squared, then plus 3A, which is, then you take this on this side, okay? It becomes minus 324, which is equal to what? 0, okay? Let me extend this one here, like that. So this is a quadratic in A. Now we are going to solve this one using the calculator to see whether it is factorizable. Mod, equation is 5, then 3, that is quadratic, so we have 2, then we have 3, and then we have minus 324. So we get a 12, and then negative 27 over 2. Negative 27 over 2. Okay, so A is equal to negative 27 over 2, and also A is equal to 12. But you need to show the examiner the attempt to solve the quadratic equation. So just like before, give us a factor that gives us this root. So you cross multiply, then you will get 2A. Then bring this one here. It will give us a plus, so plus 27, right? Then this one, put it here. We shall have A minus the 12, which is equal to 0. Okay, but then when we go back to our question here, they said that these are positive constants. You see that? So you pick the value of A that is a positive. So therefore, A is going to be equal to 12. And if A is equal to 12, B is twice it. That means B is going to be equal to 24. As simple as that. Then but B, they are saying that find the sum of the first 20 terms of an AP. Now, sum of the first n terms of an AP is n over 2, then into 2a, then plus n minus 1d, not see? So n minus 1d. What is our n? So n is going to be 20. So 20 over 2 into the first term. Remember, right from here for AP, it is a. Okay? It is a. So what is our a? Our a is 12. So we shall say 2 times the 12, then plus, this will be 19, then times the d. What is our d? Our d, we found it here as a over 2. So times a, which is 12, then over 2, not so? So that means here we shall have 10, and then here 24, then plus, this is 19 times 6. 19 times 6, we can have 6 times 20. What do you get? 120. Then minus a 6, that one will give you the 19 sixes. So 120 minus the 6, that is 114. Okay. Now when we multiply these ones here, of course 24 plus the 14, that will be 38. Yes. So we have 138, then times 10, which will be 1380. That will be our final answer. Question 9. The diagram shows part of the curve with this equation, and the lines x is equal to 5 and y is equal to 1. The shaded region enclosed by the curve and the lines is rotated through 360 degrees about the x-axis. And then they want us to find the volume of the solid of revolution here. Now we need to know these points of intersection here, but of course here the x coordinate is what? 5, but we need to know this one here. So for intersection, y is equal to 1, not so? This is the equation here. Y is equal to 1. Then we also have x, y squared is equal to x minus what? 2. So what do we have here? I will say 1 squared is equal to x minus 2. So bring this one here. That means x is equal to what? 3. As simple as that. So that means this one here is going to be a 3. Okay. Now the shaded area here, it is in between the curve and the line here. So we are going to look at the volume below this curve minus the volume under this one, the line after rotation. You see that? So what are we going to have? We are going to have volume here. We are rotating about x-axis. That's why I'm putting Vx. You know that it is pi. Then from A to B, y2 squared, then minus y1 also squared dx. How does this one come about? When we rotate this one about the x-axis, okay, we shall have something like this down here. Okay, you are rotating. Okay, now we are going to have strips in here. So those strips there, if I pull out one like this, it is going to resemble that of a cylinder. You see that? It is going to resemble that of the cylinder. And the radius here, in the middle, the r here, is going to be equal to, this is an ordinate. It corresponds to the y coordinate. So we shall get a y there. And then the change in x here will be equal to the what? To the edge. So between the two x coordinates here, that will be the height of that cylinder. Okay? And we know that volume of a cylinder is equal to pi r squared what? H. Now for this case, volume of one small cylinder is going to be pi y squared and then delta x. Now for us to get the volume, all of these cylinders here, okay, we are going to integrate. Integrate is to put into one. Integral, integrity, same person, in and out. You get it? So you put it all together. Now, when we put everything all together, that is why we are integrating from A to B. But you are getting this region here. So it is the one which is above minus the one that is below to get what is in between. Are we there? So this implies that we are going to get, so that's why you are seeing this what? This pi here, and then the y here is being squared, and then the dx. So y is here squared because it is the radius, and then the dx here, that is our height. Okay, now we need these two lines. So we need the y squared for this, and it is already given as a y squared, but even this one will be squared. So that means we are going to have pi here, and then we are integrating from 3 to 5. Okay, these two x values, and then we have x minus 2. Suppose we were given this curve in just terms of y, okay, just y, we would need to find its y squared, because that is the one we substitute in here. Are we together? Good. Then we shall subtract 1 squared here, you see, for this other one here. Or if we had another equation here of the line, then we would also get its y squared. So let us first simplify this one here. We're integrating from 3 to 5, and this one will be x. 2 minus 1, that will be minus 3, not so. Now, when you begin the process of integration, you take away the integral sign, then you replace it with the brackets. Increase the power by 1, divide by the new power, the same thing here, and then 5, then 3, and then when we put these limits, we shall get pi, then put 5, that will be 5 squared. 5 squared is 25, not so. Let me just write 25, then out of 2, minus 3 times 5, that will be 15. Then to go to the lower limit, you put a minus, so 3, put it here, that will be 9 over 2, and then 3 times 3, that one will be a 9, not so. And by the way, it is a minus 9, so the whole of this is in that bracket. So we simplify this. This is 2 times 15, that is 30. So 25 minus 30, isn't that negative 5? So we shall have negative 5 here over 2, and then here 2 times 9, you get negative 18. Okay, there. So 9 minus 18, that is negative 9. So negative 9 over 2, but then it will become a plus because there is a minus here. And then 9 minus 5, what do you get? 4 over 2, that is a 2. So the answer becomes 2 pi. And that is that. If you want, you can write it to 3 significant figures, but I can just leave it there. Question 10 is coming from trigonometry part A. Prove this identity. In proving identities, we can begin from the left side and then we get the right side, or you can begin from the right side to get the left side. Okay, so beginning with the left side, this is 1 plus sine x out of, many times it can be challenging to begin from the right side. Okay, so let us start with the left side. Now, to avoid making mistakes, do you see this thing here? This whole fraction is subtracted from this one here, you see? So I'll put this one, let's say, in brackets, because the minus here affects whatever is here, you see? So, and of course, for fractions, to get the common denominator, we multiply these two, then get this one times that, get this one times that. So we shall have 1 plus sine x, then times 1 plus sine x. In fact, I can just write this one as this one squared, then minus also 1 minus sine x, is squared. You see that? Then out of, this is 1 minus sine x, and then 1 plus sine x. Now, don't you see that this is a difference of two squares? If you want, you can expand this, then expand this, and then you subtract them. But I can see, using this identity, a squared minus b squared is equal to a plus b, and then a minus b, I can just come here and I say, get these two, okay, add them. So 1 minus the sine x. Then after that, we subtract them, okay? So we have 1 plus sine x, then minus 1 minus sine what? Sine x, like that. Then we divide by, and again, right from here, it is also difference of two squares. 1 minus sine, 1 plus sine. You see here, a plus, a minus. So that means I can just have this one as 1 squared, then minus sine squared of x. If you want, please take your time and then you expand. No problem. But then here, this sine cancels with this. Then 1 plus 1, you get a 2. Then inside here, what do we have? This one will cancel with this one here when you open the brackets. Then this is sine x. So a minus and a minus makes that one a positive. So inside here, we shall have 2 sine of x. And then this one here is, of course, 1 minus sine squared of x. So what do we have here? 4, then sine of x, and then down here, we are going to have cos squared x, okay, using the Pythagorean identity. Now, this is the same as saying 4 sine of x, then we are dividing by, there is a cos of x here, there is also another cos of x here. Sine over cosine is a tan, not so. So we shall have 4 tan of x, then down here we are remaining with what? With a cosine of x. So do you see that what we are having here is what is on the right side? So that is that. Part B, hence solve this equation here. So hence means begin from where you have stopped. So we know that this part here is 4, then tan x out of the cosine of x, not so. Then this one will be equal to 8 tan x. Okay, now there is a mistake done here. You can divide all through by tan, but when you do so, you are killing a solution. So just cross multiply and then you put everything on one side. Then you do what? You factorize. Okay, so when we do so, this will be 4 tan of x, then which is equal to 8 tan x, and then cosine of x. Okay, bring this on this side. We shall have 4, actually 4 can go here 2 times, but maybe to leave it there, I can say 4 tan x minus 8 tan x cos of x, then this one is equal to 0. So 4 tan x is common, then here I'll get a 1, and then here I'll get a 2, then cosine of x. You see that? Now you can get this one here, 4 tan x, you equate it to 0. That means x is going to be equal to the arctan of 0. And the arctan of 0 can be 0, can be 180. Okay, it can be 360. Then when you come to this one here, 1 minus 2 cos of x, you equate it to 0. You'll have 1 is equal to 2 cosine of x, and then a half here is equal to your cos of x. So meaning x is going to be equal to the arc cos over half, and this one can be 60 degrees, okay? But in radians, this is going to be pi over 3. Then it is also, cos is also positive in the fourth quadrant, where we say 2 pi, then minus the pi here, the acute angle we have gotten, but they just need angles from 0 to pi over 2, that is the first quadrant. So this simply implies that your x is going to be equal to, pick the 0 here. Don't put degrees, because when you put it there, it will be in degrees, but yet this one is what? The domain is given in radians. And then the next one here will be pi over 3. That is that. Now, suppose you had divided through by tan. Like you reach here, you divide all through by tan. Because it was common here. That means you would only get this answer here. This is what you will remain with. Then you get this pi over 3. So do you see that you would have queued this solution here? So when it comes to these trigonometric functions, in the equations, don't divide through. Put everything onto one side and then you factorize. Then you get a solution, which you would lose when you do what? You divide all through. Okay, so that is that. Question 11. The gradient of a curve is given by this, where k is a constant. The curve has the stationary point. This one, find the value of k. Now, we know that for stationary points, dy dx is equal to what? 0. So for stationary points, dy dx is equal to 0. Okay, so what is our dy dx? And here, our x is actually equal to what? To 2, not so? For the stationary point. So meaning I will come to this one here, and then wherever there is x, I'm going to put a 2. Then after that, I will equate this one to what? To the 0. Then make this k the subject of the formula. This is 6 minus 5. You'll get a 1. So 1 cubed is a 1. So you get 6. Then this way you are going to get 4k. So that means k is going to be 6 out of 4. Not so? By 3, you will get by 2, you'll get a 3. Then by 2, you'll get a 2. So that means k is equal to 3 out of 2. As simple as that. Then part B, find the equation of the curve. Of course, here we just need to integrate the dy dx. Because remember, these ones are inverse operations of each other. So to go back to the equation of the curve, you have to integrate what was differentiated. You see that? So we integrate this one here. But I'm going to replace the k with the 3 over 2, okay, of x squared here. And then with respect to x, increase the power by 1. So I will have 3x here minus 5, then to the power of 4. I will divide by that new power, then times the derivative of this one here is a 3. Okay, because this one comes from, we call it the chain rule in differentiation. So when we differentiate, we multiply through. Then for integration, we divide through. So you have to do it. And when you don't multiply with this derivative of what is coming from here, you get everything wrong. And then here, we are having a minus. We are integrating, remember, this is 3 over 2, then times x to the power of 3, then out of 3. And then we put a constant, because we don't know the constant that disappeared when they differentiated. Okay, now simplified, this one will be, of course, 12. 6 over 12 will be a half. So that will be a half of 3x minus 5, then to the power of 4. And then this one will go. Then we shall have minus a half of x to the power of 3, then plus c. You see that? Now, for us to get the value of c here, we shall come back to this point here. This point lies on the curve. So if a point lies on the curve, that means its coordinates must satisfy the equation of that curve. So using this 2 and then negative 3.5, our y is that negative 3.5, and then the x is the 2. So we shall have a half, then into 3 times 2, which is a 6, then minus 5, that will be a 1, then power 4, again that one is a 1. And then here we are having 2, then power 3. So what is our c here? Our c is now going to be this negative 3.5. Already this one is 1, okay? So minus a half, because times this a half, it will be a half. And then this one will be 8 over 2 8 over 2 will be a 4. So when it crosses, it will be a positive because here it is a minus, right? And then we get here our answer for C as what? This one is a 4 minus 3.5. You get a 0.5. Now, 0.5 minus a 0.5, isn't that a 0? So that means C is equal to what? 0. So meaning that the equation of that curve is just going to be this one here. So I'll just copy it and then put it here. Then that is my answer. Part C, find the second derivative. Now, when we go back here, our stationary point, our dy dx is given by this, right? So we have 6 dy dx is equal to 6 into 3x minus 5, then power 3, then minus, our k is 3 over 2. So 3 over 2, and then is it x squared? Okay, x squared. Then the second derivative, remember, you differentiate what is differentiated. So it is d dx of dy dx. That's what it means. So we are going to have, now drop this power here. You get 6, then times the 3, then 3x here minus the 5. Reduce the power by 1, so it becomes a 2. Then enter inside here, you differentiate this. That is 3 using chain rule. Then drop this one here. We shall have 3 over 2. Then times 2 and then x. Because when you reduce this 2 by 1, then you get a 1 there. Okay, then from here, we shall have 18 times 3. Isn't that a 54? So we have 54 into 3x minus 5 squared, and then this one goes, and then you have minus 3 of x. So after getting that, then I think that is it. This is our second derivative. So the 2y dx squared is equal to, let me just pick this one here, and then I put it there, and that is that. Then part D, determine the nature of the stationary point. So we use this one here. We substitute the x coordinate in here. Then if we find that this one is positive, then it is a minimum point. If it is a negative, then it's a maximum point. So we are having this point here, negative 3.5. Then the second derivative here is going to be equal to what? You have 54, then times, this will be 3 times 2, which is a 6, minus 5, you get a 1, then square, that will be a 1, then minus 3, then times the 2. So we shall have 54 minus a 6. Of course, here you are going to get a positive answer, which is 40 what? 48. So this is 48, which is greater than 0. So hence, this one has to be a what? Minimum. So hence, minimum. You just write that and you go away. That is that. Lastly, question 12. This one is coming from circular measure. Now, this one was, I think, one of the challenging circular measure questions they have ever set. Okay, but let us look at it. The diagram shows a cross section of 7 cylindrical pipes, each of radius 20 centimeters, held together by a thin rope which is wrapped tightly around the pipes. The centers of the 6 outer pipes are A, B, C, D, E, and F. Points P and Q are situated where straight sections of the rope meet the pipe with center A. Then part A, show that the angle PAQ is pi over 3 radians. Now, let's go to this diagram here. When I look at it, I'm going to draw this one. I bring it to that. I connect these ones here, the centers. Now, which shape do you think we are forming here? The shape is a hexagon. Do you see that? In fact, let me make it dotted such that it doesn't interfere with the diagram which was given there. Okay, as simple as that. Now, you are having this one here. Let me in fact use red. You're having this one here. You have this, you have that, you have these straight edges here, which are actually tangents to these circles. You see? So because they are tangents to those circles, then the angle between the tangent and the radius, you know, that it is supposed to be what? 90 degrees. Not so. Now I'm going to bring this one, let's say to this here. Let the color be blue. Bring this one here. This one here. Even this one actually will be there. We also take this one there. There is this one here. There is this one here. Okay. Then there is that one there. Okay. This one here. There is this one here. There is this one here. Here. So these angles are actually going to be all the same. So let me again make these ones dotted. So this one is 90 first of all. Okay. The angle between the radius and also when you look at this one, it's a rectangle, not so. So this one has to be 90. And also this one here is 90, not so. This one is 90. And then what else? So we need to get this angle PAQ, which is the theta. That's what they want, okay? But what is the angle here? From your O level, okay? From your O level, you know that the interior angle of a regular, what? Polygon is going to be equal to n minus 2, then times 180 degrees divided by n. This n minus 2 is the number of triangles you form in in the shape. For example, if you have let's say a quadrilateral, this one here. So when I do like this, how many triangles do I have? Those are two triangles. Then when I get, let's say, a pentagon, okay? So this one looks ugly. So like that. Then from this one point, I can draw here. And again, from this one point, I can do. So how many do I have? 3 triangles. But the sides are how many? 5. So if the sides are n, then the triangles will be n minus 2, because from 5 to 3 is a 2. These are 4 sides. So from 4 to 2, don't you get n minus 2? Suppose we have a hexagon like this one we are having here. So from this one point, draw a triangle, draw there, and then another one there. How many triangles do you see there? 4. So from 6 then to 4, you see that? 6 to 4. So it is n minus 2. Okay. Now that's why we say that it is n minus 2. Those are the triangles, but each triangle sums up to 100 and what? And 80 degrees. Are we there? So if this one is 180, 180, 180, 180, then you will get the sum of the interior angles. But for a regular polygon, the angles, all the angles are equal. So this one is equal to that, is equal to that, is equal to that, is equal to that for a regular polygon. So because of that, then we divide by how many they are. So this is the sum of the interior angles, then divide by how many they are. You see that? All right, so that means I'll take everything here off, and then we write this one here. So we are going to have, this is a hexagon. So it has 6 sides. So 6 minus 2, that will be a 4. Then times 180. A hexagon has how many sides? 6. So you have 4 times 180, that is 720. And then divide by 6. 72 divided by 6, that's 12. So this one will be 120 degrees. Okay? Which is the same as 2 pi over what? 3. You see that? Which is the same as 2 pi over 3. Now, let me take this one off and then try to stretch this one up here. And then So this one here is 2 pi over 3. So you will say, you will begin by finding angle, okay? Angle FAB is going to be equal to, then I can write this one here, 2 pi over what? 3. Okay, we can have 4 times pi over 3. And then another thing, so you need to first find how you got this one here. Okay, so it is 4 times, in fact, let me, since we are doing things in radians, I will just say 6 here minus 2, then times, this will be pi, then over 6, then this one will give me the 2 pi over what? 3. Then this angle PAQ will be equal to, angles at a point sum up to 360 not so, which is 2 pi, then minus, what do we have here? That one is going to, I mean, this one is 90. So 90 is pi over 2. Then there is another 90. Then there is this 2 pi over 3. Now, 90 and 90, that is 180. So 2 pi minus pi, that will be a pi, not so? So we have pi minus 2 pi over 3. So you have 3 times pi, that is 3 pi, minus 2 pi, that one will be pi over 3. As simple as that. And that is what they wanted us to find. The next, find the length of the rope. The length of the rope, we are going to look at actually the perimeter. So there is an arc here. Let me use red so that you see this well. There is an arc here, same as this, same as this. Remember, all of these circles are identical. There is also this one, there is this one, there is this one. So we shall find the length of that arc times 6. Are we there? Then there is this straight edge. This is 1, 2, 3, 4, 5, and then 6. You see that? So let's go. Let me put these ones off. We go back. So each straight section of the rope, let me in fact write that. Each straight section of the rope, okay, this one is going to be equal to, look at the radius. They gave us, these circles have a radius of 20, okay? So if this is 20 centimeters up to here, okay, even this one is 20 centimeters. And if this one is a rectangle, this side here is the same as this side, not so. So that will be 20 plus 20, which is what? 40. So we can have 20 plus the 20, which is what? 40 centimeters. You see that? Then each curved section of the pipe, we're not looking at the pipe here. Is there a word like a pipe? Yes, cylindrical pipes. Okay, each curved section of the pipe then is equal to the arc length, which arc length is given by r what? Theta. So what is the radius? The radius is 20 times the theta we have gotten, which is pi over what? 3. You see that? That means the total length. So the total length of the rope is going to be equal to 6, then times, because remember I told you these lengths are, this is 1, 2, 3, 4, 5, and 6. And then also the curved sections are 1, 2, 3, 4, 5, and 6. You get that? So we are going to say 6, then times these two that we have gotten here. So times 40, then plus 20 pi over 3. And our answer here is going to become 240. Then 3 can go here 2 times, not so? Then 2 times 20, you get 40 over 3 pi. And were the units given in centimeters? Yes. So that means the perimeter here is going to be in centimeters. I can leave it there. Or if you want, you can write it to 3 significant figures. But I'm going to leave it there. Then, let's see, find the area of the hexagon. This one giving your answer in terms of root 3. When you come back here, area of the hexagon here, if I try to connect, let me use now smaller width. I connect this one here. I connect this one to that. Then this one to this one here. So do you see that we are getting, let me also make these ones dotted. Just make them dotted like that. Do you see that there is this triangle here? Let's get this. This triangle here is the same as this one here, same as this one, same as this one, same as this one, and same as this one. So there are 6 triangles in there. So I get area of one triangle and then I multiply it by 6. Now look at what is here. This angle here is 120. Then when we divide it by 2, it will be pi over 3. Okay, this angle here, pi over 3. Now that means even this one is pi over 3. You can even see if this one is 20 centimeters, even this one is 20. This one is 20, this one is 20, this one is 20, this one is 20. So don't you see that this is an equilateral triangle? So if it is an equilateral triangle, that means all angles are equal. Then this one is pi over what? 3. So meaning if I have this length here and I have this one here and the angle in between, then I can find the area of that triangle. It's a matter of getting the A. You have the theta, you have the B. So it is a half, then A times B, and then sine of the angle in between. You see that? So now that simply implies that the area of the hexagon, area of hexagon A, B, C, D, E, F, this one is going to be 6 times area of the equilateral triangle. The equilateral triangle. So this one is going to be 6, then times the area is going to be a half, then times we have a 40 times a 40, then sine of the angle in between, which is pi over 3. So this one can go here 3 times, not so? Then 16 times 3, that one gives you a 48, right? But then there are these 2 zeros here. And then sine of 60 is root 3 over 2. Then this one can go here to 4,000, not so? I mean to 400. So 2,400, then root of 3. That one is going to be our area here. It will be in centimeters squared in terms of root 3, and it is there. Then lastly, we are having find the area of the complete region enclosed by the rope. Now you can see in here that we have gotten area of this hexagon. Then we need to get the rectangle here. Do you see it? There is this other one here. 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 Those are 6 rectangles. You see that? If those are 6 rectangles, we are also having sectors. So there is this sector. There is this one here. 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 And then there is this one here. So we are going to say that the total area is going to be, so total area is going to be area of hexagon, okay, then plus 6 times the area of rectangle, then also plus 6 times the area of the sector. Now, area of the hexagon, we have gotten it as this, not so? So we shall have 2400 root of 3, then plus area of the rectangle. When I come back here and I check the rectangle, this is, of course, it will be length times width. So there is this one, which is 20, and then times this one, which is what? 40, not so? So we shall have 6, then times, this is 20 times 40, then plus 6, then times area of the sector, so it will be a half, then r squared. If we check back, of course, the radius is what? This one is the same as this, it is all 20, not so? So that will be 20 squared, then theta. The theta is this one we got here, which is pi over 3, okay, the one that we found here. So that is pi over 3. And then what do we have here? So 2400 root of 3, and then this is 8 times 4, 8 times 6, that is 48. So I'll have 48, then 00, and then this is a 6 here, it cancels with that 6, and then we remain with 400 of pi. So plus 400 of pi. So if they had asked for the exact value, then this would be the exact one here, centimeters what? Squared. But we can write to 3 significant figures. 2400 root of 3, then plus 4800 plus 400 pi. This one will give us 10213. Or to 3 significant figures, I can write this one as 10200, 10200 centimeters what? Squared, and this will be to 3 significant what? Figures. So that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.